In this video, we're going to take a look at factoring trinomials where a is not equal to 1. So remember, we're referring to a as in ax squared plus bx plus c, our standard form for quadratic functions. So the a is that leading coefficient. So when that is not equal to 1, like you can see on our examples, then we need to use this method. The other method would not work. So let's take a look. We want to factor out a greatest common factor if possible, always with any type of factoring we do. Then we're going to multiply the a times c like we did before. We're going to find factors that will multiply to give us a, c, and add or subtract to give us b. And then what we want to do is rewrite our trinomial as a polynomial of 4 terms and then use grouping, the method that we've already covered. So let's first take a look at, do we have a greatest common factor? So I see I have 2, 11, and negative 21. There's not a number other than 1 that would divide into those 3, so we're not going to take out a greatest common factor this time. So let's go ahead and multiply the a times the c to get started. So 2 times negative 21 is negative 42, and then we want to always add up to get our b value, which is 11. So let's write out what are some factors of 42 that would help us to get 11. We notice that the 11 is positive, so our larger number is going to need to be a positive. So let's say 42 comes from 1 times 42 and 2 times 21 and 3 times 14. And what you can do if these numbers are not just popping in your head is use that calculator trick we've talked about before. So let me show you that again. So if I go to y equals and I want factors of 42, and I could either use 42 or negative 42, but we can figure out our signs in just a minute. So I'm just going to type 42 divided by x and then do second graph to bring up my table of values. So see, I've got 1 times 42, 2 times 21. They're just listed in your table. 3 times 14. Skip over the decimals. And then we have 6 times 7. And then 7 times 6. So then it starts to repeat itself. So then we want numbers that would help us get 11. So you want to see what numbers are 11 apart from each other. So 1 and 42 are definitely too far apart. 2 and 21 are too far apart. And 6 and 7 are too close together. But 3 and 14 are 11 away from each other, and so they're the numbers that we need. So I'm going to put 3 and 14. But we need to multiply to get negative 42, so one of them has to be a negative. And the 3 would need to be negative, so they'll still add to give us a positive 11. So what we do next, let me move my calculator out of the way. We're going to write the polynomial, our trinomial, as a polynomial of 4 terms. So you're going to take the 11m that you have as a b value, and you're going to use these numbers that we figured out to rewrite it. So I'm going to put 11 is now negative 3m plus 14m. So notice negative 3m plus 14m does equal 11m. So I haven't really changed what I have. I've just rewritten it in another form, which is always okay with math. So now I'm going to bring down the first term and bring down the last term, and I've rewritten the middle term, so all is good. And now I have 4 terms, and I can use the method of grouping to finish factoring this trinomial. So let's group the first 2 and the last 2 terms and take out greatest common factors from each. So 2m squared minus 3m would have m as our greatest common factor, because both of those would divide evenly by m, but then we can't take out anything else. So then I would have 2 and an m left from the first term, minus 3, because the m would cancel out from the second term. Remember to take out the sign of that third term, so that'll be a positive. And then 14 and 21, 14 will not go evenly into 21, but they will both divide by 7. And once again, let me remind you of that calculator trick that we did earlier in our videos. If you need help with numbers like that, 14 and 21, remember you can pull up the functions menu in Desmos and go all the way to the bottom and choose GCD and type in the 14 and the 21. And that can help you come up with what's the largest number you can divide evenly by, which was 7. Okay, so moving on, we got 14 divided by 7 is 2, and we have an m that would still be there. And then 21 divided by 7 is 3, so that'd be a -3. And remember with our grouping method, these two that are left over should be the same. And then we're going to put together the factors we took out. So m plus 7 is one factor, and then one of those that's matching is our other factor. All right, so that's it. It just takes an extra step when your a value is not equal to 1, because you've got to get it into 4 terms so that we can go ahead and use a method we're used to, which is grouping. So let's take a look at number 2. So first we can see, can we take anything out of 4, 8, and 3? And 3 is prime, so it won't come out evenly. And so let's go ahead and multiply the a times the c to get started. So 4 times 3 gives us 12. We want to figure out numbers that will multiply to give us 12 and also add up to -8. All right, so 12 comes from 1 times 12 and 2 times 6 and 3 times 4. So things that would help us to get 8. So 2 and 6 will help us to get 8, but they both would need to be negative, so they add up to -8. And then 2 and 6, when they're negative, will both multiply to give us a +12. So the -2 and -6 are our magic numbers. So what we need to do next is rewrite our trinomial as 4 terms. So 4x squared comes down, and then in place of -8, we're going to put -2x minus 6x. Because notice those are equivalent to -8. If I were to put them back together, it would give me -8x. So I haven't done anything that is wrong. That is perfectly mathematically sound. So let's group the first 2 and the last 2 terms and take out greatest common factors from each, because now we're just using our grouping method that we've seen before. So from the first 2 terms, I see that I could take out a 2 and an x as my greatest common factor. So let's write that in the front. And then we have 4 divided by 2 would be 2. And x squared divided by x would leave us with 1x. And then minus 2x divided by itself, which is just a 1. Always take out that third term's sign, so it's a negative. And then I see that 3 is our smallest number, and 3 would go evenly into 6. So let's take out a -3, and then we can't take out an x since the 3 doesn't have one. So then -6 divided by -3 would be 2, and we still have that x. And then 3 divided by -3 is a -1. So notice by taking out that sign from the third term, it helps these two to match, which is what we want with this type of factoring. So bring together your greatest common factors. So 2x minus 3, and then one of the ones that's the same. All right, so that is it for our second example. Let's do a few more. So we have 6b squared plus 5b minus 4. 6, 5, and 4 will not have a greatest common factor because of the 5 is a prime number. Prime, remember, is meaning that it only comes from 1 times itself. And then 5 doesn't go into 6 or 4, so we don't have a greatest common factor. So let's multiply a times c. So 6 times -4 is -24. And then we're going to add together to get b, which is 5. So let's think about numbers that would help us to get 24 when we multiply and 5 when we add. So factors of 24 are 1 times 24, 2 times 12, 3 times 8, 4 times 6. So numbers that are 5 apart from each other. So 1 and 24 are too far apart. 2 and 12 are 10 apart. but 3 and 8 are 5 apart from each other. So those would be the right numbers. And then let's look at the signs. They need to multiply to be a negative and add up to be a positive. So this is the one where you want your larger number to be positive. So we want to make it a -3, because -3 plus 8 would give us +5. And -3 times 8 would be a -24. So let's rewrite our polynomial. So we have 4 terms. So we have 6b squared. We have 5b, which we're going to rewrite with our numbers we figured out would help us to get that number. So -3b plus 8b. And then bring down the last term, which is -4 or -4. So group the first two and group the last two. And then we're going to take out greatest common factors from each binomial. Let me scoot that over a little bit. So on the first pair, we can take out a 3 because they both divide evenly by 3. And then we can also take out a b since they both have at least one b. So let's write that out front. So 3b, and then 6 divided by 3 is 2. And b squared divided by b will just be 1b. Then minus 3b divided by itself is just 1. So that's it for the first group. The second group, we're going to take out a positive, and we can take out a 4 because that's our smallest number, and then it does divide evenly into 8. So take out the 4, and then we would have 2b minus 1 left over. Notice we do match. We always want to check on that. And then let's write the 2 that we took out together. So 3b plus 4 goes together as one factor, and 2b minus 1 is our other factor. Okay, so that's it for number 3. Let's look at one more good example of trinomials where a is not equal to 1. So 7, 19, and 6. Again, there's no greatest common factor. We could use Desmos to check and make sure, but 7 is a prime number, so it won't work unless 7 were to divide into the other numbers, which it would not. All right, so we've checked all that out. Let's multiply the a times the c again. So 7 times -6 gives us -42. And then we always want to add together to get the b value, which is -19. So numbers that give us 42. So we've looked at this one before. We have 1 times 42, 2 times 21, 3 times 14, and 6 times 7. So you want to look at numbers that will help you get 19. So they should be 19 away from each other. So 6 and 7 are definitely too close. 3 and 14 are only 11 apart, and 1 and 42 are too far apart. But then just in the middle there, 2 and 21 are 19 digits apart from each other. So those are the numbers we need. So let's put 2 and 21 and then look at our signs. We need a negative when we multiply. So one of them is going to have to be a negative, and then they have to add up to be negative. So the larger number needs to be a negative. Remember, the larger number has to go with the b value, in other words. So let's rewrite our trinomial as a polynomial of 4 terms. So 7m squared plus 2m minus 21m. Remember, because those would add back together again to give you what you started with. So that's why that's okay. And then bring down the -6. Group the first 2, group the last 2. Take out the greatest common factor from each. So in the first pair, I'm going to take out an m. And I would have 7m plus 2 left over. And then in the second group, I can take out a -3, because that's the largest number that would go into 6 and 21. So -3. And then I would have 7m plus 2 left over again. So then put together your greatest common factors. They become a factor, so m minus 3. And then one of the ones that looks the same is our other factor. So 7m plus 2. All right, so that's it for factoring trinomials where a is not equal to